We are going to be checking out StyroPyro building a Soviet military tech death machine. Yeah, so I'm just going to put it out there right now. Don't do anything he does. Just don't. Run away screaming. If you know anyone who finds this interesting, say that's nice, pat them on the head, and then book the closest flight. Not a plane, not a bus, flight to the other side of the country for safety's sake. It's the only way you can deal with that. If you're in a small country, move to Canada. There's plenty of open space. If you like the cold. If you do, nice. Oh God, we're going to jump right in and see just what he blows up with this one. Not sure that's a joke or not. And Takamara just going, oh God, no. Oh God, yes.
I recently came across these Tesla arc lighters on eBay, and for how cheap they are, I couldn't help but buy a couple to screw around with.
You can, they're lighters, but do they literally just shoot it's essentially a taser. You're lighting a cigarette with a taser. A non-modulated for safety taser. Oh, of course.
I love electricity and I love fire. So anything that combines the two is definitely going to grab my attention. I mean, seriously, what could be more fun than a device that can burn stuff with an electric plasma? So today I'm going to test
he's not wrong.
these things out and maybe make a few upgrades. So yeah, I hope you enjoy this video.
A few
now,
upgrades?
Before I go on,
oh
I
God,
all the crazy
he
stuff
did say
you're about to see
Russian
was done
tech.
completely for educational purposes. I mean, if you were to try any of this stuff at home, you'd probably die. So yeah, please don't try this at home.
Alright, so here's what came with the package here. So you got some instructions, a USB charging cable, then of course the lighter. I guess there's a little safety switch here in the back.
Oh, it's not USB-C either.
Alright, here goes nothing.
Oh.
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 Huh.
Oh, it's 4 different streams converging or separating. Oh, that is actually really cool. I don't smoke, but I kind of want this, is what I would say, except I know for a fact I would do something stupid and cause a fire. There's a lot of things I think are cool that I know for a fact I will never let myself buy because I would do really dumb shit with it. Yeah, I am that kind of idiot.
Huh, you call that a plasma lighter? Jeez. Yeah, that's basically blasphemous to put Tesla's name on something like that. Huh, I was expecting...
Yeah, we can't all have the aesthetics of a cyber dumpster. Truck.
Something a lot bigger than this. Yeah, this thing is definitely going to need some upgrades.
It does look pretty cool, though.
You know, I probably shouldn't get carried away just yet.
What's he going to
do?
do?
I should at least test out its burning capabilities. Can I light some alcohol? Check. How about some paper? If I can get that. Check.
Oh, yeah,
how about a match? Cool. So it can definitely light things on fire, so that...
His table is on fire, but it's not actually being... Oh, he must have a table that's heat resistant. I didn't see what it was before, so I just assumed wood, but no, because it's not spreading. It's literally just burning off the alcohol he put down. Oh, that's really cool.
That's good.
But even so, I still haven't seen it do anything that a cheap butane lighter can do. But I guess I haven't tested its electrical properties yet, so maybe something there will impress me.
What?
Can it light LEDs?
Oh, yeah, it does actually light
pretty
them.
Interesting.
Is it going to blow up?
You can't do that with a regular lighter. How about some neon bulbs? Oh, wow, that's actually pretty bright.
You could see this. Oh, it's 2 sparks on each side. Wait. It's 2 sparks on each side. Doesn't it have to have the current go through it to work? Also, Takamara, you mentioned you almost forgot about the Indomitable Garrison Spirit by the Endless Tavern Mate. You know, I need to check this out. I do not know what it is, though. Also, don't know if any music would be claimed or not, so I don't want to risk it on a stream if I'm not aware already. I only do Guild Guide because it's only ever claimed music, not blocked music. Is what I would say, except the first video after a week did get blocked, so...
Neat. Alright, this one's for science. Ow, holy
Why?
Crap, that hurt. Jeez.
Must be low amperage and low volt.
Okay, so I'm not that impressed with this thing. I mean, it can light things on fire, I'll give it that. I mean, if it's going to have the Tesla name on it, I expect it to be able to melt metals, or at least shoot a giant jet of plasma out of it. I mean, Nikola Tesla could have come up with something much more impressive 100 years ago. So it feels kind of disgraceful to sell for something like this. I think it's time for some upgrades.
Let's start with the obvious upgrades. Can it drive an 8-stage Cockcroft-Walton voltage multiplier stack?
What?
Well, I mean, yeah, but it doesn't make the arc that much bigger, so it really isn't worth the trouble.
Surprisingly loud.
Maybe I can just feed it higher voltage for a bigger arc. Taking it apart shows that it has a 3.7 volt lithium-ion battery inside. So by removing
Only
that,
3.7,
I can
not
hook
bad.
the lighter up directly to a variable power supply and crank up the voltage. Alright, here I have it hooked up to 4.2 volts, which is the equivalent
I miss how many volts did he just say? Oh, Tudor, it's AI music. I might check it out on my own time, but I probably wouldn't do it on stream then. Just because YouTube, when it comes to AI, anything has very unique rules that I'm not entirely sure I understand yet.
and crank up the voltage. Alright, here I have it hooked up to 4.2 volts, which is the
Okay,
equivalent of
a little
having
more.
a fully charged battery.
Oh.
And
Oh, he's
Huh.
bridging the gap with that.
that's weird. Why isn't it making an arc? Well, I guess I can just crank up the voltage until it works, right? Okay.
Why do I think Sunny's going to start smoking? Oh, yeah, there he goes. The board is
Okay,
smoking.
So it's just literally going to do nothing. I'm not really sure why that lighter didn't even start up, but I only have one backup, so this time I'll try upgrading the transformers before stepping up the voltage.
Oh? Oh,
Well,
yeah, it
at
worked.
least it works. It's really no different than the original. Let's step
But it was actually breaking a bit before it came into a steady arc. I wonder if it's because it ionized the air between it and kept it there.
up the voltage a bit there. Yeah, the arc's definitely a bit hotter now. I mean, the circuit is drawing more current.
He would
But
need
it's still
bigger
nowhere
areas.
near
Oh,
impressive.
yeah, and you can already see some of the smoke coming from
Let's
this.
keep on cranking up the voltage and see what happens.
Probably burn the board. Oh, yeah, that
Oh.
board is on fire.
Okay.
Oh, you can actually see. It's not just the board, it's the wires that are burning. Oh, can we actually see the exact moment they lit? Okay, so a lot of that is probably reflected light here. Let's see, as he cranks it up, it starts right in the middle where I think the solder burns. Oh, no, it's not the solder. It's actually the board right there. Oh, I see. And it's going up, and then the new light source is going off the wires, so they're not actually burning. Oh, dude, it looks like the connection point down on this side. Dude.
Okay, so it's just gonna break that easily. Wow.
Time to make his own?
Alright, so I think my hopes of modding these things were a bit far-fetched.
Oh,
I mean,
God.
seriously, even a charged capacitor of this size isn't that exciting.
Huh, that was actually pretty cool.
Okay, so my point is, go big or go home, right?
How big are we
I
talking
guess
here?
I'm just gonna have to build my own giant one from scratch. But what kind of circuit should I build? I mean, I could always just make a scaled-up version using huge transformers and transistors.
Yeah?
Now, honestly, the cool factor there wouldn't match the lethal factor. I mean, really, this little 2-electrode thing is kinda lame anyway. A Chad plasma lighter would use a single electrode to generate a flame, and just use capacitive coupling to complete the circuit.
What?
So what I'm suggesting is a Tesla coil, right? Well, only kinda. What I'm thinking of is a lot more dangerous.
When it comes to high voltage, I tend to choose more archaic methods of power switching when I can. I mean, my biggest Tesla coil uses a frickin' angle grinder to switch the tank circuit.
That's what that is? Of course, an angle grinder. Also, heading out Zenith? All right, thanks for dropping in, man.
But it does generate some pretty cool results. I advanced
I'm sorry, I just want to clarify.
results.
This is his previous weaker attempt. Oh, boy.
I advanced to the 20th century with my last Tesla coil build. It's based on a vacuum tube,
Oh?
and the device actually does satisfy the single electrode requirement.
Yeah?
Unfortunately, it's lacking in the setting fire to things department.
Considering it's your
I mean,
hand, that's probably a good
seriously,
thing.
It takes a while to get third-degree burns from this thing. Now that
Why?
being said, tubes are still the easiest way to make a super hot arc using just one electrode.
Why?
It turns out that at high enough frequencies and powers, you can generate an incredibly hot arc that resembles a real flame. When this is done on purpose, it's usually in a circuit dubbed the high-frequency vacuum tube Tesla coil. Now I should clarify, this is the name given by hobbyists to a terrifying circuit that only has some characteristics of
Touch equals die. So it's literally a death flame. Okay. And Xeno Dragon, you're heading to bed? All right. Have a good night, man. I'm just going to sit here and watch a guy make a flame from hell out of electricity. At that point, is it just plasma?
traditional Tesla coils. Now, I'll get more into what makes this circuit so scary later, but the first red flag is the fact that the first Google result for the general schematic is this cursed thing.
Oh god.
The thing is, a circuit using a puny 55 watt rated tube isn't going to satisfy my pyromaniac desires, but it at least provides a good starting point. Besides, I already have this awesome piece of Soviet military surplus on hand.
Why?
This is a GU5B triode, which is rated for several thousand watts of output power. Naturally, I bought it on eBay, and it looks like...
Okay, actually that makes sense. Of course it's eBay. Several thousand watts. Oh boy. Sure. This is safe.
It's like this one sat around in a warehouse for the past 38 years. I can only find two other people that build an arc lighter from heck using this tube. There's Zillypoper, whose videos actually scare me, and Teslista555, who makes some awesome high voltage control.
I'm sorry, did I just mishear that?
Whose videos actually scare me.
Okay, he's Russian? Yeah, that makes a lot more sense. Because as much as StyroPyro plays the mad scientist, he's playing the mad scientist. He's heavily aware of exactly what he's doing to keep it safe, because anyone else not knowing what they're doing would probably be dead by now. So him saying someone else's videos scare him is probably him commenting on, oh yeah, no, this guy's not being safe about it. He's Russian though, so it kind of makes a lot of sense. Come to Russia, we will do things that will make you wish you had died of psoriasis from drinking.
And Teslista555, who makes some awesome high voltage contraptions as well.
That's voltage?
Both have excellent channels with great high voltage content, so you should definitely check them out. Their builds provided a great reference for mine. I started the build by making a filament supply for the tube. I got a good deal on this toroidal transformer on eBay, and I clipped off a few of the windings to match the proper filament voltage under load. I also added a soft start to the circuit using some relays and big resistors. For the resonator coil, I wound some copper tubing on cardboard pipe. I used cardboard here because PVC and pretty much any other material available in pipe form would cause high dielectric losses.
Oh.
Now, actually powering this circuit turned out to be a lot harder than it should have been. As you've seen on my channel before, I tend to accumulate a lot of old microwave ovens.
How many?
For this special occasion, I decided to use the...
You know, considering what the last video was the microwave laser cannon, sure, why not?
Two biggest microwave transformers that I had salvaged during these past couple years. I threw them in an ammo can, encased them in wax, and
why does he have a random ammo can laying around?
On top. And if that wasn't enough, I used this supply to drive a huge voltage doubler. For the caps I used these chonky things, and for the HV diode I used a bunch of lower voltage diodes potted in wax in a PVC casing, and then threw a couple doorknob caps across those for good measure. As a side note, I can't break out microwave transformers on this channel without pointing out how incredibly lethal they are. They kill more electronics hobbyists than any other component, no joke. That being said, even as terrifying and lethal as this power supply is, it just couldn't hack powering my cursed arc lighter circuit. The voltage just sagged too much under load. At this point, I would have just went out and bought some more thrift shop microwaves to cobble together a bigger supply, but you can't do that this year. So I turned to my shining light in the darkness.
Wait. Oh, yeah, 2020. So this probably came August 2020. Yeah, there's a reason he couldn't go out. Also, I kind of need one of these masks for fume extraction. Apparently just can get into the eyes if you don't cover them, and the option I had doesn't quite fit.
eBay. With a bit of searching, I came across a great deal on this huge transformer salvaged out of a flashlamp pumped laser. The transformer was a great fit, but it didn't solve all the circuit's issues. Now, not all the issues were bad per se, but you know what? Let me just show you how it runs.
Yeah, he's not beating the rap on the mad scientist thing. Look at this and tell me it's not literally out of cyberpunk or steampunk or retropunk. It has a vacuum tube, so retropunk might be more accurate.
So
what's it going to do? Slow start. Appropriate switch with big dial attached. Yeah. Okay, that is oddly satisfying. Oh my! I'm not sure what this is like for anyone else, but hearing the initial one on headphones, it goes from a very small, low level to blah, at a much higher resonating pitch than I was expecting. So that actually was shocking, like legitimately, because it hit the frequency where maybe it's just my earphones, but they were vibrating a lot at that. Throw a ball at it, see what happens. It's actually igniting the air. You can see where it is igniting the air around it.
Ah, yes. There's that angry hot plasma that my puny little arc lighters couldn't give me.
Yeah, plasma. You can actually see it. It's like there's a lot of the electricity itself, the plasma, the ionized air, and just the remains of the burn. It just... Okay, yeah, sure. If this man ever runs for anything professional, run. Because he can probably do it.
Now remember, I'm not feeding any gas in there.
What?
That crazy flame arc is just the air being ripped apart by the electromagnetic field. Now to be fair, the flame didn't...
I assumed it was just the air. Is he going to not put gas in there to make it more so? Probably not. That would be really dangerous. I don't want to think about this because that is literally blowing up a house dangerous. Why? Also, Mega Man Land Prime. You wish to invite you to the Merrick's Evil Council of Doom. Your reaction to our evil and we shall defeat Yugi and the Pharaoh. I thought I had seen that years ago though. Maybe not. Hard to remember.
It looked like this when I first powered up the circuit. It turns out that coming up with an electrode that can withstand these conditions is pretty difficult.
Oh?
On normal Tesla coils, a breakout point in the form of a piece of copper wire is often added to control where the arc is directed.
Oh.
When I tried that with this overclocked pseudo-Tesla coil, it didn't exactly work as intended.
What, did it just melt it? Oh shit, it's actually burning the metal!
That's right, it melts copper wire like wax. Now this is pretty crazy because not only does copper have a melting point of over 1,000 degrees Celsius, but most of the output power is actually going into the air around it, not the metal. So how about a steel electrode? The melting point of that is a few hundred degrees higher than copper, so it should be a better fit, right? Not quite. It turns out it burns like a fuse when hooked up to the output of the resonator.
Hi everyone and welcome to the 4th of July Sparkler event. Congratulations, you win death.
Coil.
You can actually watch the flame just eat away at
Steel
it.
is a pretty good conductor in low frequency circuits, but its relatively high magnetic permeability means that its apparent resistance due to the skin effect becomes pretty significant at high frequencies. This means that it absorbs quite a bit more energy from the circuit than the copper did, and this is pretty apparent as the steel melts a lot easier even though it has a higher melting point. Now, I can't say I've ran into the issue of liquefying copper and steel electrodes before, so coming up with a durable electrode turned out to be quite a challenge.
At what point does he just buy an arc welder? Because at this point, it's kind of what he accidentally made, except way more dangerous.
But then,
Oh shit. No. I am covered in cat hair. Ah, that's my neck. Ah, that's my neck.
know that plasma can get over
Tungsten.
3,400 degrees Celsius, which is pretty awesome in its own right. But still though, I need a way to not burn through electrodes every 10 seconds. Now there's only one other element on the periodic table that has a higher melting point than tungsten.
Oh, that's cool. He actually has a periodic table with the individual pieces of it shown. And also noting which ones
Not
are...
burn through electrodes every 10 seconds. Now there's...
Yep. The picture of the people who discovered them, who they were named after, because they can't actually see them because they're probably theoretical. And noting that they're all radioactive. Oh. So 43 is, and then it jumps up to 84 for the next radioactive one. Huh.
There's only one other element on the periodic table that has a higher melting point than tungsten, and that's good old-fashioned carbon. It turns out that my favorite element is available inside lantern batteries in the form of graphite rods.
Really?
By opening it carefully, I can see the four
Why does he have a
individual cells that make
machete?
up the overall battery. Each one of the cells has a graphite rod, and these should be able to handle the extreme conditions on my plasma generator.
I get the joke of open them carefully as a machete, but also, why does he have one? I saw it in the previous video and I asked the question, then I still don't know.
Plus, all that manganese dioxide in there will be useful for other reasons. To top it off, the rods fit conveniently snug inside some 3/8" copper tubing. And since graphite is so soft, it's easy to grind the ends into nice breakout points for the plasma.
Oh.
So without further ado, let's see how these hold up. It looks like graphite is a clear winner. Some of the carbon is still vaporized, but it's slow enough to not be a huge deal.
Yeah, it's not immediately dying down.
But now that I have an electrode that won't turn into a puddle means that I'm ready to spice things up a bit. That's right, I'm breaking out the chemicals.
What?
With the help of various metal salts, I can not only make the arc longer, but I can also make it produce some crazy colors.
Oh, joy! Colored death plasma. My favorite. Also, Mega Man Land Prime, you mentioned, how am I enjoying the videos for our future overlord that will take over, handle those who oppose him? I am submitting. I have no problem with this. I have never had a problem with this. Ignore any comment I might have about his sanity. That definitely is not the case, and he is perfectly safe to be around. Is he still watching? Because I need to run away now.
Now, adding salts to the running coil would be risky to say the least.
What?
But by drilling a small basin in the graphite electrodes, I can pack them with chemicals and deliver salts to the flame that way.
So he's actually putting a burn chamber within the directional aspect. Oh, that's actually kind of fascinating.
I also found it helps to paint the area around it with a saturated solution of the compound. This electrode is loaded with sodium bicarbonate, aka regular old baking soda.
Really? Oh, it has that much of an effect. Is he using a tinted light, or is it just that orange? It's just near to the pitch change.
The sodium is what gives the plasma that brilliant yellow color, but it also helps increase the flame size. My reasoning for this, at least, is since sodium doesn't mind losing an electron, I'd expect it to hang around in an ionized state, and that would increase the free charged particle density in the outer regions of the plasma.
So not only does it have the power to be plasma on its own, he could add things to make it more plasma. Huh. So he literally has a plasma flamethrower of variable length with actual charges embedded in a small but durable supply. If you found a safe way to contain this that wouldn't arc back to you, this is something right out of 40K, man. This is the heavy flamer.
This would help keep the escaping gas conductive for a longer time while it cools, and it would also provide a seed for avalanche ionization of the air around it.
Avalanche ionization?
Alright, sodium was fun, so how about we try the element above it?
How bad could it be? Oh, dear God! It's not that high of flame, but when everything goes purple, pink, red at the same time, and I'm not sure which color is which, yeah! Okay, sure!
It turns out lithium gives an incredibly deep red plasma on the generator. Now this isn't that much of a surprise considering it gives the best red flames of any element that I've burned at least. Unfortunately, most lithium salts are highly hygroscopic, so that's why you don't typically see them used in fireworks.
Oh, it absorbs water.
Next, I tried an electrode loaded with copper 2 chloride. I can't say I'm that
just straight
impressed with
white.
this one. I was hoping for a deeper green or deeper blue than that. I think the arc
It's probably not being caught in whatever camera he's using because it does not seem blue or green at all. Maybe there's a flash around it, but I can't see shit.
is just too hot and the color is getting washed out by blackbody radiation. At the minimum, though, it does give a bit more color to the plasma than a bare copper electrode. Now, there were a few other disappointing electrodes that I tried, but I'm just going to skip to my favorite one.
I'm sorry. It's what? I know in chemistry, when you add extra anything to it, it is not the initial compound. It's why water is not flammable, but if you break into its parts, it very much is. But cesium chloride. I know half of that is, oh dear God, what the fuck? And I don't know what he's about to do would maybe change that or not.
An electrode loaded with cesium chloride. Now the colors here aren't that crazy, but it does give the biggest increase in flame size of all the salts that I tried. Since cesium is the least electronegative element on the periodic table, it's surprisingly stable, floating around as a singly charged positive ion.
We have created cesium flamethrowers. Normally, this is where I would say something along the lines of, do not let Kyle Heel find out about this. Except last week, someone went into the comments. It's like, yeah, no, don't worry about it. I went into the comments. I've been leaving an obsessive amount. He will find out. This will happen. Lovely. And Mega Man, you mentioned, would you be interested in reacting to the diabolical trial of Shredder? I've never heard of that, so I have no idea.
Like the sodium salts, it provides free charges to increase the plasma size.
It does
but
look pretty
cesium
cool
does
how
an
big
even
it is.
better job at it.
What would happen if he mixed them? Would it compound for length and color? Or would it just kind of neutralize because they don't interact well? Or would they interact better than he's assuming? I'm not a chemist. I have no idea.
If it weren't for Justin Atkin of the Thought Emporium telling me about cesium lightning rockets. It turns out that an alternative to using tethered wire for rocket-triggered lightning is cesium-spiked rocket fuel. The long hang time of the ions can provide an adequate conductive path to trigger lightning in a thunderstorm.
Oh.
Apparently, if it works for lightning, it also works for this plasma generator. I do look forward to the day when I can try this with actual lightning, though. The last salty electrode that I
This was in 2020. In the it's actually later than that, 4 and 2 months, 4 years and 2 months since then, has he decided to go full on, it's alive, and harness lightning with cesium pellets? Everything I just said is wrong in so many ways.
I tried used a roughly 50-50 mix of cesium and lithium chloride.
Oh, he actually did mix them.
This was a good trade-off between arc length and color.
Yeah, apparently it worked.
The arc was nearly as long as from the cesium salts
But you can
alone,
see where the
but with a
cesium is
strong
going
red hue
and the
from
arc
lithium.
burns off earlier. Ah.
Everything I've
Oh, I wonder if you could actually do layers of color if you could mix them in at different levels. Because the red was there for the ion or the lithium, and then the arc went beyond that when it burned out. Pretty cool, actually.
put on this coil so far has been endothermic for the most part. That means that the chemicals absorbed energy by going into the plasma. But the thing is, I'm surrounded by all this reactive oxygen. It would be a shame letting that all go to waste.
What?
And since fire is conductive, my thinking is that I should get some really interesting results if I use flammable conductive electrodes.
What?
For the first angry electrode, let's start with magnesium. When magnesium is burned the normal way, it produces a blindingly bright white flame, and this is a pretty classic chemistry demo. So what happens when it's ran on the incinerator coil?
It's going to be gone in seconds. And Mega Man just basically said, he's attempting to become Zeus. That's not fair. I don't think he aims nearly that low. Oh, it's green at the base. And red.
That's weird. Why is it making every color there is? Like
Oh yeah,
seriously,
yellows,
this thing is switching
red,
between
green.
red, green, orange, white, and sometimes all of them at once.
Yeah.
I have no explanation for this. Now the red's the most crazy to me because it's so deep. I've never seen magnesium produce these colors before.
The green is very
In fact,
vibrant
I'd be really
too.
curious to hear input from my viewers on this. Since I had such crazy
What
results
the
with the
hell?
first electrode, I made another magnesium electrode, but
This monstrosity.
with a lot more pieces of ribbon this time.
Oh, that actually looks really cool. Oh.
This can
Oh, there's actually 3 distinct points that had the biggest burn going. I wonder if splitting the ends actually reduced the amount of... It probably did split the voltage.
configuration didn't produce that striking red color like before.
But there's a lot of green.
Instead, this one made a bunch more violet and green plasma. Now these colors weren't nearly as vivid as the red
And they're
was,
jumping around,
but
too,
either
where it's
way,
the strongest.
It's still pretty awesome because it's considerably different than the typical white flame.
Yeah.
I had a smooth brain moment in one of my magnesium tests and
What?
forgot to move the ribbon away from the coil. And this actually ended up shorting out the coil a few times. Oh boy.
That does not look good.
Now you have to admit, It looks pretty cool.
Yeah.
But it's probably not good for my tube.
No.
For the next metal electrode, I used some zinc that I salvaged from the
I have
batteries
no idea
I
what
took
zinc
apart
would do.
earlier. Now this one wasn't as wild as the last one,
Straightforward.
but it did produce some nice blue colors as it burned on the coil.
Oh yeah, I see a little of the blue. I guess maybe it's the color correction he's using. It looks more purple around the edge to me.
In my experience, zinc tends to burn green in most pyrotechnic mixes, so the blue color was a bit of a surprise. I tried an electrode made out of ferrocerium, which is the alloy used in modern lighter flints.
Oh, that's how that works? Oh, I didn't realize it made sparks that easily. Huh.
Now this one was surprisingly tame. I was honestly hoping it would explode or something. Now it did manage to create an incredibly bright white plasma. The brightest...
So that's not actually the camera having flickers. That's the camera not able to adjust to how bright it is. I wonder what it would look like in person. Probably blinding. It would definitely be blinding.
Out of all the electrodes I tried, actually. The steel wool electrode turned out to be
God, this is
one
gonna be
of my
gone in
favorites.
seconds.
Even at relatively low input voltages, the steel wool ignites super easily and makes a nice shower of sparks.
You could hear it hitting the coil. Surprisingly,
Now,
it's lasting longer than I
igniting
thought.
reliably once the outer wool burns off, but luckily, that can just be fixed by raising the voltage.
What? Oh God! That wasn't all the way up?
Now I know what you're thinking. Is there anything useful you can do with this circuit? I mean, if you didn't know any better, you
Murder?
might think that this is all just a dangerous and complicated way of starting a fire.
I mean, yes. Yes, it is.
For starters, it's great at driving incandescent bulbs. That's right, why use two wires connected to mains when you can use this awesome single electrode light bulb driver?
How long till it pops?
At first, the circuit doesn't draw much power and just ionizes the gas inside of the bulb. But as it heats up, the melting glass becomes conductive enough to draw more power and really start to glow. I find that 60 Hz hum coming from the voltage doubler to be really soothing.
It burned up the coil on the inside. It burned up the gas on the inside. And we are currently looking at the glass igniting. Surprisingly, it's holding up better than some of the other metals. Not a lot better, but it is. It's the moments where he just turns it off.
What a great use for vacuum tube technology. Plus, when the bulb reaches end of life, you're left with all these awesome glass beads.
They actually do look pretty freaking awesome. If someone hasn't made this in our
This can drive
project.
a lot more than just incandescent lights. In fact, a plasma globe lights up super easily on the coil. Since the operating frequency is nearly 1,000 times higher than a stock globe, the plasma takes on some unusual forms compared to how they typically operate.
Oh, actually, is that a reflection or is it doing a smaller version below it? Probably a reflection.
Cranking up the power makes it much brighter as well. Unfortunately, the inner electrode on this one quickly melted through, which is why the plasma is turning yellow here. But even as the globe starts to take on air, it makes some absolutely stunning patterns that are totally worth the short-lived nature of the device.
This electrode is what melted first. What would happen if he made his own I'm almost wondering if he might make his own electrode to make a giant version of this, just to see what he could do.
Ice.
That is really cool, though. We have reached full Kamehameha blast in real life.
Oh, shoot. I need to charge my phone, but
What?
I forgot to bring one of Apple's proprietary connectors to my shop today. Maybe I can just
I fully stand by this usage of Apple technology in a way that is definitely not in any way, shape, or form going to harm anyone. You know, better than Apple.
wirelessly charge it with a coil. Maybe I didn't give it enough power there. Let's
What?
give that another go. Huh, don't worry about that. That was just the voltage doubler arcing over. Well, it doesn't seem to have charged
Oddly enough,
the
it
phone,
still
but
has
did
the
take
ability to
care of
show
the problem.
anything.
All right,
Oh, I
one
thought it
more
would blow
test
up.
for the coil. Can it
Is that
cook an
an
onion?
onion?
One way to find out.
Well, is the onion burning through? It is burning through. Because it's arcing into the connection point. Yeah.
I'll take that as a yes.
Man, this project has been so much fun. Like, seriously, this is my spirit circuit. It's sketchy, chaotic, and great at lighting things on fire.
Yeah, sounds about
But
right.
it's also extremely dangerous, even in the context of Tesla coils, which is definitely saying something. Now, it turns out that there's actually very little info on this circuit online, so I wanted to go over some of the key details for those that are interested.
First off, I want to compare this to a traditional vacuum tube Tesla coil. Superficially, they both look pretty similar. Both circuits use a vacuum tube that drives a resonant circuit to make plasma, and they use many of the same parts in their construction.
But
That's about where the similarities end, though. The most obvious difference is in the choice of coils. A traditional Tesla coil uses 2 or even sometimes 3 coils in the design. The output coil usually consists of around 1,000 turns of relatively fine wire, and usually a metal top load of some sort. Now this circuit only needs a single coil to operate, and my coil here only has 20 turns.
did it burn? No, he actually has the cutouts already in the cardboard. Oddly enough, the cardboard never burned, even when they literally were shocking things down it and throwing liquid metal on it.
Unfortunately, using one coil means that you lose isolation. In the traditional design, the output coil is not directly connected to the rest of the circuit, and instead is coupled to it via
What would the isolation
electromagnetic
change?
fields. This isolation is part of the reason why I can touch the arc and not instantly die.
Oh, okay, that would be why. Yeah, that's a good reason.
Wow, it tickles. Now, I definitely don't
Yeah, not the word
recommend
I would
that you
use.
try this, but it does demonstrate some interesting properties of the circuit. Another major factor is that by touching the arc, I introduce quite a bit of capacitance into the circuit, and this causes the resonant frequency of the output coil to drop. This knocks the circuit out of tune and dramatically decreases the amount of energy the circuit can deliver.
Oh.
That
And that's probably why it's safe, because it's out of tune, it makes it less powerful.
brings up the most important difference between the circuits.
This would
If
not.
you touch that arc, you die. The output coil here is hooked directly to the high voltage power supply. That means that the circuit doesn't have to be producing plasma or even oscillating to kill you. If
Oh.
you touch the coil while the power supply is live, you're a corpse before you hit the floor. If the risk of instant death syndrome wasn't enough, you also have to consider the potential for RF emissions from the device.
RF?
This circuit oscillates at a much higher frequency than a typical Tesla coil.
Oh.
Over 10 megahertz actually. Considering the circuit is drawing over 5,000 watts at max power.
So I don't know nearly enough about RF resonance or frequencies. What exactly would that do? Like, does it
There's
interfere with
serious
electronics
potential
or?
for causing RF interference. Now this circuit is a terribly efficient radiator as the vast majority of the energy
Oh, the
goes
steel
into
wool,
the
yeah.
plasma, but it doesn't take much EM radiation to become a problem. I don't know if you noticed, but I upgraded my Faraday cage specifically for this project. I covered
Oh.
every surface with fine mesh copper and then painstakingly soldered the seams together.
That's all copper. You know, I shouldn't be surprised because he does crazy shit already. But copper is expensive, man, and that is a lot of it. On the other hand, the alternative would be he dies, so yeah, it's probably worthwhile.
I spent more time building this stupid cage than the actual plasma generator. It certainly beats angering the FCC though, or even worse, local hams. Interestingly,
hams?
when the circuit is first fired, the breakout actually looks quite similar to a Tesla coil.
Oh.
But this initial plasma channel is quickly heated by the large amount of RF current that goes through it. As this happens, the arc starts to take on more thermal characteristics, and convection
Looking
draws
like
it upward,
heat?
giving it a more flame-like appearance.
Really?
Now, if you're wondering
Wait. Oh, because convection is pulling up the already heated air that's moving through, so it looks like heat because it's following the air it's already ionized, essentially. Okay.
how the circuit
Huh.
actually works, it isn't super straightforward. Now, my understanding is that it operates as a Class E oscillator, and the chaotic plasma is the load. Now, this is actually super complicated to model, and that's why optimizing a circuit like this comes down to just trial and error.
Now, I'm not kidding when
The
I
trial
say
and
that
error
there's
or
little
luck
info
and
on
not
this circuit
dying?
online. In fact, when I first learned about the circuit, the few builds that I could find were all from people in Eastern Europe, and I just assumed this was because they had access to cheap Soviet vacuum tubes. But then I watched Viduli's video on the phenomenon.
But actually, I have a little bit of confusion here because I haven't found a proper English name for this discharge.
I guess I was just searching in the wrong language. According to Viduli, this phenomenon is well documented in the Russian language. And
Oh.
the first paper on the effect was written way back in 1928 by a Soviet
Plasma
scientist.
flame.
Interestingly, he also found footage from slightly earlier showing Americans that built an RF torch of their own. Now, even though Americans may have been the first to demonstrate the effect,
Oh.
there's very little info on it in English. Now I can go on and on about other
RF
weird and
torches.
problematic properties of the device, like sketchy methods of igniting
So we've
the
had plasma flamethrowers
or
for a
how
while.
changing the electrode can double the power draw, or how in the course of a minute it turns the atmosphere of my shop into literal poison. But at this point,
Because all the burn shit, not just the ozone from the air, but everything else would also be... Yeah, he probably has a really good fan in there.
this video is already my longest yet, so I should just pull the plug before I get carried away.
I'm sorry. Before he... What?
Video is already my longest yet, so I should just pull the plug before I get carried away.
This is him being restrained. Oh. Good to know. That's terrifying. Oh God.
Now before I end this video, I want to thank the YouTubers that inspired this project. Because I'll be honest, I wouldn't
Stop
have known
inspiring
how to go about building
him.
this crazy circuit if I didn't have their builds as reference. As far as I know, Zilly Poper was the first person to build
Just
a torch
doing that in
circuit
his
using a
house.
GU5B triode. It's funny because I tried building the circuit as close to what I could make out from his videos, but I couldn't get it to work with his values of grid caps. It's probably just because my brain is too smooth to comprehend his RF wizardry. Tezlista 555's build is what inspired my use of a voltage doubler on the drive supply for a more chaotic flame, and his salted electrodes are what gave me the idea to put half the periodic table in my coil. I wish I would have used his clever coil design though, because it looks way nicer than the one I wound on cardboard.
Okay. Yeah. These guys are all somehow more insane than he is.
Finally, I want to thank Viduli for sharing some of the history on this type of
Plasma RF
device,
torches.
as well as for his previous designs I've used in my videos. This guy is legit. He actually researches in a facility that studies huge pulsed power systems. If you guys are interested in high voltage, be sure to check these channels out. They've got a ton of awesome content and they're certainly
I will
more
run away
qualified than I
screaming
am to
from
build
these
this
men.
stuff.
Women,
Well, I guess
whatever.
that's about it for this video. So until
Is
the
that
next time,
overcharged
stay
physical?
safe and
It's a
happy
physical, yeah.
blazing.
He actually did... I think we can all just acknowledge right now that there is no sane world where anything he just did should be possible, which is further proof that this is not a sane world. Every step of the way there, I was just going, it can't get worse. And then it just got weirder and worse. Don't get me wrong. That was so cool. But also, you gotta die if you touch that shit is usually the starting point of something along the lines of, and then they touched it. Yeah, StyroPyro is insane. I love his content. I love seeing what he does. But I'm also terrified whenever he has an upload that hasn't been in a while because everyone else has said, yeah, we're always surprised when he's alive. And I'm just sitting here going like, his last video was about having cancer. Not what I thought would get him. Also, poisonous amounts of testosterone from cancer from what I heard. I haven't seen his latest video. I'm a little scared to check it out. But I probably will at some point. And to quote Elan Gaming in the chat, sanity is overrated. I would agree. Which is why I was an English major. I don't have that to start with. Still better than a philosophy major. If you know, you know. Either way, you guys know the deal. There's a link below to the StyroPyro's video. Hit it up. That was amazing and also batshit terrifying. And I just remembered to leave a like. So that's a good thing. Yeah. So I'll see you in the next one.